So today we will be learning about the periodic table. So can you raise your hand if you have ever heard about the periodic table or like a little bit familiar with it? Yeah? Okay, awesome. But like you don't need to answer anything, but for now we're just gonna learn about it. So to get started, today we will learn about the elements and the periodic table, in case I haven't mentioned that. So as a quick brainstorm, I wanna ask you guys, what do you know about elements? And just like a hint, that it's not fire, earth, and water and air. And so can you guys share, what do you know about elements, and do you think you can name any? All right, I can start. I know that oxygen is an element.
You know hydrogen's an element?
Yeah, exactly. Hydrogen is an element. Does any other guesses of what it is or types of elements?
Is silicon an element?
Yeah, silicon is an element. That's a really good guess. I'm impressed you knew that. Awesome. So basically, an element is the simplest substance possible. So it can't really be broken down into smaller parts. But we'll learn a little bit more about that later. And basically, everything around you is made up of elements, right? But this is kind of crazy to think about. There's only 118 elements known to man, but yet there's millions of types of substances, right? So the answer, like, how can everything in the world be possibly made up of only these 118 elements? And the answer is the elements can form. They can combine to create new substances, but we'll learn a little bit more about that in a few slides. So basically, the smallest part of an element is an atom, which you guys may or may not have learned about. Basically, these atoms are made out of subatomic particles, such as neutrons, protons, and electrons. Can you raise your hand if you've ever heard about these? Awesome, yeah. So basically, protons and neutrons, they kind of go together, and then electrons orbit them. And the neutrons have no charge, protons positive, and electrons are negative. But again, I'm pretty sure you guys are familiar with that, which is awesome. So we have to ask ourselves, how are protons, electrons, and neutrons related? Basically, yeah, the protons and the neutrons are together in the nucleus, and then the electrons orbit them on the outside. And also, in a neutral atom, the electrons and protons must be the same amount, right? So the positive and negative charges can equal each other. So I wanted to ask you guys, is this what is showed up on the screen? Is it a neutral atom?
I don't think so, because there's 3 electrons and only 2 protons.
Yeah, exactly. So it is not a neutral atom. It is actually a negatively charged ion, because there's one more electron than there's protons. Awesome. And so I remember I was talking a little bit earlier about how elements can combine to create new substances. And this is what we have on the screen. So basically, molecules are combinations of 2 or more atoms. So for example, you can have a O2 molecule, which is 2 oxygens that form a bond, and this is a molecule. You can also have compounds, which is specific groups of atoms from different elements. So for example, carbon dioxide is a compound because you have 2 different types of elements that are combining. Another example of a compound is water. All right, so any questions before we move on? Awesome. So now we will be modeling an atom. And our goal with this activity is to learn about the spatial orientation of subatomic particles by building one. Well, by building a sample. Okay, so what you will need is 9 marshmallows or pieces of chewy candy. I'm using cereal. And so does everyone kind of have these, or I'll go through them. So you'll need 9 different types of candy. If you can, 3 colors would be great. And then you'll need 8 toothpicks and 3 different colored markers. Let's get started with the activity. So today we're going to be model a lithium atom using candy. And a lithium atom has 3 protons, 3 neutrons, and 3 electrons. And kind of looks like this. All right, so the first step is to take your 9 pieces of candy or paper and separate them into 3 piles of 3. So you can, if you're using marshmallows, color these each a different color. And if you're using paper, cut these into 9 circles, and again, make 3 piles of 3. And also, if you're using circles, make sure to color each of the piles into a different color. So they should look a little bit like what we have on the screen. The next step is to label each either candy or circle with a dark marker. So let's all use a different sign for each neutron, proton, and electron. So I can show you guys. So here I have, this is what we will be creating, but I will label each one of these as a proton, so a plus sign. So like just a clarification, if you're using like green M&Ms, like you have 3 green M&Ms, make sure you label all of those 3, all of the green ones as like protons, or it can be any. Yeah, but make sure that they, the same types of candy or the same colored candy has the same symbol, if that makes sense. The next step is to, you will connect the neutrons and protons into a ball. So we should have 8 toothpicks, so using 5 of them, we will connect the, wait, hold up, I think it should be more than 5, but that's okay. We will be connecting the neutrons and protons into a tightly knit ball. So what that means is I have 3, these are cereal, I have 3 of them labeled protons, and I'm going to connect them into a triangle, if that makes sense. So take your toothpicks and connect the protons with each other, but then you will also intertwine them with the neutrons, which will create the nucleus. Okay, so we can continue to do this while I introduce the next step. The last step is to take the last 3 toothpicks and connect the electrons. So the nucleus was kind of the harder part because they have to be tightly wound together. But then lastly, just connect the electrons with the toothpicks to the nucleus. It doesn't really have to be in a specific order. Yeah. So there should just be protons and then neutrons in between them, but it's kind of up to you how you would want to organize that. And then once you are done with the nucleus, we will put on the electrons. So maybe take like 1 or 2 more minutes to do that, because I would really like to move on to the next. We're going to be doing a chemical reaction, which is pretty cool. Okay, so let's wrap it up now. If you're not done, that's perfectly fine. We're going to have a 5-minute break, and you can continue working on it, but you can also like get a snack and stuff. Oh no, wait, mine just fell apart, but this is what it looked like, and then there was a goldfish on the top, but it just fell apart, which is like funny. Yeah, so just should be like a nucleus and then the electrons floating around. I have Cheerios and a different type of cereal as the protons and neutrons in the nucleus, and then goldfish swimming around as the electrons. If yours doesn't look exactly like that, that's perfectly fine. Okay, so let's move on to our break. If you haven't fully completed the nucleus or attached the electrons, that's perfectly fine. You can continue doing that during your break. But let's do some discussion questions. So I want to ask you guys, it's okay if you're not done, by the way, I don't want to scare you guys. Do you guys think that an atom of lithium truly looks like this model we created? So if you were to go outside, is this what lithium looks like? Yes or no?
I think, like, I've read books about these, and, like, there aren't actual, like, lines connecting them.
Yeah.
And, like, the electrons, they're not really orbiting. They're just, like, it's like they're appearing somewhere.
Yeah, that's actually a really good answer. Also, so there's many things different about actual lithium atoms. To start, atoms are way smaller than the model we created. And also, they are like orbiting and not in any, like they're kind of orbiting randomly, but they're not connected. They're not, like our model doesn't move, it's just like stiff. So yeah, really good answers though. So now we're gonna move on to the periodic table of elements, and then hopefully we'll have time to do our second experiment. So basically, a table, oh my goodness, wait, sorry, 1 sec. So a table is a way to organize information. For example, like a periodic table, a table of contents in a book is a way to organize all the chapters in a book. And just like that, a periodic table is a way to organize all the elements, and they are organized by their properties. But like, here's a little bit more descriptive. How is the periodic table organized? So each box represents a different, each box represents a different element. And in that box, it tells you a lot of information, right? So we have the atomic number, which is the amount of protons. We have the symbol, for example, H stands for hydrogen. And we also have the atomic mass, which is how much they weigh. So you guys don't actually really need to memorize this or anything. We're just trying to familiarize you guys with it. So basically, from the periodic table, it tells you a lot. It tells you all the different elements, and how many protons they each have and their mass. Awesome. And if you can see on the periodic table, they are organized by atomic number. So we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 118. And again, these numbers are the amount of protons. Okay, so quick, any questions on what the periodic table is or how it's organized? Or do we have a relative understanding? Pretty good? Okay, so let's move on to the experiment. So we will be making volcanic lemons. And our goal is to apply the knowledge of the elements and observe a chemical reaction in the real world. Okay. So here are the materials you will need. You will need a lemon, scissors, a little bit of baking soda, a spoon, a container, small container, and then paper towels and an open workspace. So take a few minutes to get all these, and they will be on the screen for your reference. And then once you have the materials, the next step is to cut the lemon in half using scissors, or if you have a parent to help you cut it, that will work too. Just make sure you have parent help if you're cutting it with a knife. But the next step is to, using 1/2 of the lemon, just juice 1/2. So you can squeeze out the lemon juice. Once you have your 2 lemons and one is juiced out, the one that isn't squeezed, you will mush it with a spoon. But ideally keeping the lemon juice inside. So once you have your mushed out lemon with still a little bit of juice inside, you will add a tablespoon of baking soda to it. And then you can mix them together. And it should create foam. Okay, and then once you have the baking soda and the lemon, mix it, and then you can add the lemon juice from the other lemon. So in your mushed out lemon, you will add a little bit of baking soda, mix it, and then add the remaining lemon juice. And if the experiment is going correctly, it should create foam. And then you can also squeeze the lemon to make more foam. Awesome, so it looks like we're all done with the experiment. Congratulations, guys. So we just created a chemical reaction. So basically what we did is we had the reactants and we added them. So this was the lemon juice and baking soda. We mixed them and then they created completely new products. So again, we added lemon juice and baking soda and we formed foam and water, which is pretty cool. In a more scientific way, we added citric acid and sodium bicarbonate, and we created carbon dioxide and sodium citrate, which is pretty cool. And here's the chemical formula. It's pretty complicated, and it's really cool to think that we just did that in less than 15 minutes. So the elements that we used were carbon, hydrogen, oxygen, and sodium. And they all came together to form compounds such as citric acid and carbon dioxide. So it's really cool to think that we had lemons or lime to kill, and then we added them with baking soda, and they created carbon dioxide, which is what we exhale, and sodium citrate. It's really cool that we created these new substances. So that was it. That's the lesson. So I really hope you guys had a fun time. I know I had a lot of fun teaching you guys about atoms and elements in the periodic table, and I like the lemon experiment. I did it earlier. Thank you so much, guys.